Hello everyone. Welcome you all to this third lecture of CSE437 Symbolic Machine Learning 1. So in this lecture we will discuss about the regression tree. Okay? Regression tree. In our previous lecture we already discussed about the random forest. Over there we also learned that how to construct the decision tree for the random forests. So here in this lecture, we will learn about the regression tree. As you can see that here is also the tree. That means uh, we will learn how the decision tree like tree structured model can be used in regression purpose. Okay, so this is called the regression tree. Uh, Before going to discuss about the algorithm, that is regression tree algorithm, and the example of that, um, we have to know the definition of the regression. Okay? So the regression analysis, we can say the regression analysis is a set of statistical methods. Not only one method here for regression analysis, we can apply many methods. So these statistical methods used for the estimation of relationship. So that means in regression analysis method, we usually used this one is used for estimation of relationship between dependent variables and one or more independent variables. In regression analysis, usually we analyze relationship or try to analyze the relationship between dependent variables and one or more, that means multiple independent variables. Okay, so this is the regression. That means we will learn how the dependent variables uh, is associated with one or more independent variables in regression analysis model and try to find out that kind of model. So in this lecture, we will use the tree structured model that is called the regression. Okay, here is an example for that. Like we can say that that is the we want to predict the IQ score based on the age and the place of living. This is one actually part of some the data set. I have collected this one from the data set. So this is the age and the place of living. The age and the place of living, this is one variable, this is another variable. And we want to predict the IQ score. So that means in case of the dependent and independent variable concept, we can say that this is our target variable. Okay? That means the IQ score, if we can say that IQ score is y. So how the IQ score y is related to x is the s and maybe g. Okay, that means the place of living. Is that this is the relation, that is the direct plus something? Okay, is this the relation, or maybe we can say that the relationship is different. Okay, usually this kind of relation in regression analysis, we use the line equation. So that means we can say that so maybe it is the slope of x plus of into this is the slope with g and plus of maybe something some other parameter. Okay, so this is the linear equation near to the line equation. Usually in line equation we can say that it is defined just only with one independent and one dependent variable. Like in case of the line equation, we can say that y equal mx plus c. Okay? So in this case, the x, this is called the independent variable, and y is dependent on y. So y is dependent variable. Same thing here in this case. In our case, if we can see that, that is, we have two variables, age and place of living, and we want to determine IQ score, or maybe we want to find the relationship between age and place of living with IQ score. So we can say that this y is our IQ score, and here other two variables, that is two uh, independent variables, are age and place of living. So we have to find out like this, maybe m1 of x plus m2 of g plus c. So this kind of relationship may be called. Okay, usually in linear regression, we use this kind of equation, like line equation. But here in this case of the regression tree, in this case of the regression tree, this is also another non-linear. The regression tree is a non-linear machine learning model for regression. So that means it will not use like this, the relationship like this. It will not use. In case of the linear regression, linear regression, we use the line equations, okay, like this kind of linear equations. Sometimes also we call that is, if we have multiple, that is the independent variables, then we call the multilinear regression. Okay, multilinear regression. Okay, but the discussion of linear regression we will discuss in another lecture. Okay, but in this lecture we will focus on the regression tree. Specifically, this one is nonlinear regression method for regression analysis. So here are the parameters for determining the IQ score is age and the place of living. Then how can we construct the decision tree, and how can we analyze or maybe predict the IQ score? Okay, before going to discuss this example, just just we can see that this is the age and the IQ score. If we can plot this just age and IQ score, try to find out the relationship between the age and the IQ score. So we can easily see that that is the data points are actually a little bit scattered. Like maybe you can say that if we can apply the linear regression, maybe you can say like this. The linear regression line will be like this. It's kind of line fitting. Okay, so in such a case, here is another point. Actually, this point is not correctly fit to this line. Okay? So that means we can see that the linear regression, if we can plot the value and also observe closely uh, the, the graph, then we can see that there's just only one line is not enough for this kind of data. Okay, this kind of data is a little bit sparse. So it will be better if we can draw the multiple line. Maybe one line is in this direction and another line is like this direction. So then, okay, then in this case, in such a case, maybe we can say that we can easily get the correct prediction. Okay, so that means the linear regression is not sufficient. We can say that linear regression is not appropriate for this kind of data. We need to learn that when we need apply the nonlinear and when we need to apply the linear methods. Okay? So that's why I just plot here the scatter plot of age between age and IQ score. Just only one variable, okay, age, okay, one dependent variable and one independent variable. So here independent variable is and dependent variable is. I just plot that one, and you can easily see that it is just only one line is not enough for, for the prediction. So that means we need multiple lines or maybe some form of non-linear regression, but it may be better by this time. Okay, maybe we can say that polynomial regression, uh, specifically the support vector machine regression with polynomial kernels. So those are the perfect match for this kind of data. Okay, then the regression tree example. How can we construct the regression tree? At first, we have to see the values, that means the features. So here two features. One is age, another one is place of relation. And how can we know that this is the regression problem? Again, we have to look at that is the y levels. So these y levels are continuous values. Okay, that means IQ score can be 1, 3, 4, 5, 6, or maybe we can say that 1.5. It can be 3.25. It can be. Okay, so that means the, the target variable, or maybe you can say that levels are continuous. Levels are continuous. That's why uh, we have to learn that is this is the regression problem, not the classification. Now, second thing we have to look to the independent variables. That means the features. One feature is age, another feature is place of living. So here in the case of the age, in case of the age, we can see that these are the numerical values. Okay, numerical values, not the ordinal numbers or maybe categorical values. Not the ordinal numbers or maybe categorical values. These are the numerical values. If any data set have this kind of numerical value, then we have to think a little bit differently. Even we are even we can say that we want to uh, build that decision tree or maybe the random forest. When you can find this kind of data, like maybe numerical number, then you have to think differently. So for the categorical value or maybe ordinal number, so here is the categorical value, village, city, the category. So for this kind of data, we can easily apply the decision tree method. But for this kind of numerical value, we have to think differently. We will learn how to treat this kind of that is numerical number here for constructing the decision tree, or we can say the regression tree in this purpose. Okay, what should we do? Here we have to take the A's and the IQ score. So that means one dependent variable and one independent variable. We have to take that. And now what we have to do, we have to sort the IQ score with respect to the A's. So that sorry, we have to sort the A's and also the corresponding IQ score. So we have to sort the A's in ascending order. So that means here is 8, 10, 12, 30, 35, 60. It's already sorted. If it is not sorted, we have to sort. We have to sort and we have to change the corresponding IQ score accordingly. Okay, that means based on the age, we have the IQ score, the serial of IQ score will also be changed. So here, the age, we have to sort the age in ascending order. Okay. And then what we have to do, the average of consecutive two persons is. So now next step, what I have to do, I have to find or determine the average of two consecutive ages. Like maybe the average of 8 and 10. Average of 8 and 10 is 9. Then again, I have to take the average of 10 and 12. Average of 10 and 12. So 10 and 12 average is 11. And again, I have to take the average of 12 and 30. So the average of 12 and 30 will be 21. Again, I have to take 30 and 35. It will be 32.5. And 35 and 60. It will be 47.5. So that means I have to take the average of two consecutive errors. That is two consecutive numbers. And we will find these numbers. These are the numbers. Okay, so the first step is the sorting, and second step is finding the average of two consecutive numbers. We already determined the average of consecutive percentages. Okay, then what I have to do? The next, so I have to consider each and every the average as the splitter. If you can remember the splitter that is in our random forest. In our random forest, for constructing the decision tree, um, we discussed about the splitter. Okay, that means which splitter or maybe which feature has the most discriminatory capability. That feature we have to place at the root of the decision tree. Same thing here. We have to consider each and every average number as the splitter. That means we can consider like here is 9. Okay, so A is less than 9. So this is one splitter. One splitter. Okay, and A is less than 11. This is another splitter. And A is less than 21. So this is another splitter. Similarly, the A is less than 32.5. So this is another splitter, and also is less than 47.5. So this is another splitter. So we have here total 5 splitters. That means we can split the A's on 9. We can split the A's on 11. We can split the A's on 21, 32.5, 47.5. But we have to know which splitter is better. Which splitter is better. We have to find out that. Okay. So any question up to this slide?
No, sir.
Okay. Okay, next. So we already get our splitters. That means we have total. We have total. How many splitters? 5 splitters. So now we need to consider each and every splitter and the arrow, or maybe that if we can split using that splitter, whether it will be better or not, or maybe we can say that we need to find the better splitter from these 5 splitters. Which one is better? Okay. Uh, okay, now consider here. Okay, so considering is 9 as the separator, or maybe splitter. Okay? Considering is 9 as the separator. So at first, if we consider is 9 as the separator, uh, you have to carefully know. So see that procedure. Uh, so considering S9 as the splitter, so that means we want to consider like is less than 9. So this is our splitter or separator. So if we consider this is our splitter, then this is will split like this. So like uh, which one is less than 9? So we can say that this is the S which is less than 9. And all other, that means all other values here, all other values, these are the greater than 9. So if we think like this, that is a tree, okay, a tree like this. So here is less than 9. In this side, that means we can say that this is the left and this is the right. Okay, left and right side. In left side, uh, just this observation, that means observation number 1, S8. We will get S8 in this case, that is left side, and all other edges, that means all other observations we will get on the right side. Now what we have to do, we have to look to the IQ score of the corresponding observation or the corresponding person. Here we can see that the S8 is observation of this person with IQ score 1. IQ score 1. So that means what we can see, that is just only one observation, that is 8, and the IQ score is 1. For that person, IQ score is 1. And another case, this is the left side. If we consider the right side, so all other observations, that means in right side we can say all other observations will be there, and the corresponding IQ score will be from this. These are the IQ score of the right side. Okay, now if we can put all these things here, all these observations in right side and just left side is 1. Okay. So in right side, all other observations are here. So what I have to do, I have to take the average of all other observations, average of left side IQ score and average of right side IQ score. The average of left side IQ score, in this case, just only one IQ score is there, one. If we can do the average, it will do. It will do. Average of right side IQ score. So average of right side. So right side, that means 3 plus 1. So this is 4 plus 4, 8. 8 plus 5, 13. 13 plus 2, here is 15. 15 I have to divide with 1, 2, 3, 4, and 5. I have to divide with 5. So that means 15 divided by 5 is 3. So that means in right side, the right side, the average IQ score will be 3. And in left side, average IQ score will be just 1. So that's what we have written here. Average IQ score of left side instances, this is 1. And average IQ score of right side instances, this is 3. Okay. And then what I have to do, I have to determine the sum of square residuals. This is sum of square residual value. Okay, how can we determine the sum of square residual? That means we can say that if we use this splitter, what will be the error? Okay, so that's the sum of the square error or sum of the square zero. Okay, so a is less than 9. This is our what is criteria on a split. If we split on these a's, then what will be the error? Specifically, our target is to minimize the error. Try to find out the splitter which will induce the less error. So that should be the target. Okay, so that's why we need to measure the error. So how can we measure the error? To measure the error using the sum of square zero, what we have to do, we consider that this is the average. Okay, so the left side instances, if we just have this tree, so based on the s, just one person is just maybe the age is just 10. Okay, in this case, if we just have this tree, then, uh, how can we predict the IQ? The age is 10. Maybe some random person, like person number 7. Here is 6 observations, so uh, 7 number the person. He just mentioned that I am just 10. Okay? Then how can we predict the uh, his IQ score based on just only what we have now, based on this tree, okay, based on this tree. In such a case, what we have to do is less than 9. Is it true or false? Okay, 10. 10, this is false. That means we have to move to the right side. So this is the line. That is, this is for true case and this is the false case. Okay? If this is our tree, then what we can do is less than 9. No, that means we have to move right, and we have to say that okay, uh, predicted IQ score will be 3. So predicted IQ score will be 3. Okay, so this is the prediction. Okay, so this is the prediction. Prediction is 3. Okay, okay, so uh, hello. Can you hear me?
Yes, sir.
So, okay.
Yes, sir.
Okay, so we are talking about the prediction. Okay, so just maybe one person, his age is just only 10. Then we can predict that using just only this part, we can predict that the his prediction is 3. Okay, because it's age, based on his age, the IQ score will be 3. Okay, so that means here, if we can see that the average IQ score of left side instances is 1 and average IQ score of right side instances is 3. So based on this, we can also predict. Okay, we can also predict. If this is our prediction, then uh, what will be the error with the existing data? Okay? So this is the existing data. Then we have to calculate the error. That is the error function here is some square is equals. Okay, then at first we have to consider the left side. Left side is 1 average. That means uh, the left side prediction prediction is 1. So take, if you can see here that we have just only one observation in left side, one observation left side. The original IQ score, this is original, okay, original. The original IQ score is this, but predicted IQ score is this. For left side instance, just only we have one left side instance, this is a 1, where the original IQ score is 1, and predicted IQ score is also 1. 1 minus 1 square, sum of a square. So that means a square, we have to take the square difference, residual. And now, all other, that is the observations, all other observations are on the right side. So the original IQ score of right side, these are the original IQ scores, but the prediction is 3. Predictions. Okay. So here is this, for the case of the right side, the second observation, you can see that this is the original IQ score, this is 3, and the predicted IQ score is 3. This is the prediction. Okay, and square plus the third observation. You have to check the third observation. Third observation here is the original IQ score is 1. This is the original IQ score, and predicted IQ score is 3. And for the case of the fourth instance, or maybe fourth observation, the original IQ score is 4. Here is the 4. And predicted IQ score is 3. This 4. Here is this 4. And next, the 5, this is the fifth person, is 5, and prediction is 3. And the sixth person, original is 2, and prediction is 3. Okay, so we have calculated the sum of square residuals based on the original IQ score and our prediction, considering is 9 as the separator. If we do the math, then you will get the 10, and this is the 10. Okay, do you understand this part? This mathematics. Okay, thank you. So now, what we have to do? We have to consider is 11 as the separator. Is 11 as the separator. The same thing like previous one. If we consider is 11 as the separator, so that means if we consider is 11 as the separator, so is less than 11. So this is the separator. Okay. It will again separate our data into two parts, in left side and also in right side. Left side and right side. In left side, this is the left, so this is the right. In left side, we can see that is 11. That means in left side we will get these two. That's 8 and 10 is, and in right side we will get all other ages. Okay. So now what we have to do, we have to take the average IQ score of left side instances and average IQ score of right side instances. So here, if we can compute the average IQ score of left side instances, so that means average IQ of the left side instances is 1, 3. That means 1 plus 3 equals 4, and we have to divide with 2 because we have 2 instances in left side. 1 plus 3 equal 4 divided by 2 is 2. Here is the 2. Okay, so average IQ score of left side instances will be 2. Average IQ score of right side instances. So here, right side, there are 4 instances here, and the IQ scores are these are the IQ scores for right side instances: 1, 4, 5, and 2. So we have to take we have to determine the average of this 4. 1 plus 4 is 5, 5 plus 5 10, 10 plus 2 is 12. 12 divided by 1, 2, 3, 4, 4. 12 divided by 4 is 12 divided by 4. So it is 3 again.
3.
Okay. So here is the 3. Now, what I have to determine? The same thing, that is the sum of square residuals I have to determine. The sum of square residuals, how can I determine the sum of square residuals here? So again, our prediction for left side instances is 2. This is our prediction. And for right side instances, our prediction is 3. So the original IQ score of left side instances here 1 and 3. Okay, the first 1. For left side instances, prediction is 2, but original here is 1. 1 minus 2. 1, this is the original. 1 is our original. And this is the 2, that means 2 is our prediction. So 1 minus 2 is 5 plus original IQ score of next one is 3. So we can say this is the 3. And original IQ score for this and this one, this is also in left side, so that means the prediction is 2. So 3 minus 2 square. And another one, this is one that is for the third instance or third observation. So original IQ score is 1. Original IQ score is 1 and prediction is 3. And again, for the next one, that is fourth observation, original IQ score is 4. Prediction is 3. And fifth one, so original IQ score is 5 and prediction is 3. And for the last one, that is original IQ score is 2. You can see that the original IQ score is 2 and the prediction is 3. So take this part. And now, if we do the math, then we will get the 12. So here is the 12. The sum of the square is 0. 12. Okay, then that means sum of the square residuals we have calculated the sum of the square residuals of that is 11 as the scalar, as 11 scalar. Similarly, what we have to do, we have to determine the sum of the square residuals for is 21 as the separator, and the separator that is 32.5 and separator 47.5. I think no need to explain these things again. We have to do the similar process for all other separators. It's 21, 32.5, and 47.5. And you will get the sum of square residual like 7.33 for S21 and 11.25 for S32.5 and 12.8 for 47.5. So if you have any question on this one.
Question, sir.
Okay. So we can move on. Now, what should we do? we should consider the which one is minimum to find out the minimum one. So that means here we can see that the sum of square residuals here the minimum one is this one. That is 7.333. So this one is minimum. And if we plot the sum of square residual versus the age, okay, so here the average two consecutive numbers. So 9, 11, 21, 32.5, and 47.5. We can say that here the sum of square residuals. For 9, sum of square residuals is this one, which is the 10. For 11, this is 12, and for uh, 21, this is 7.33. 32.5, this is 11, and 47.5, this is 12.8. Okay? We can see that the minimum sum of square residuals is this one. Okay? The graph, if we just present the graph. We need to plot the graph here, but sometimes we need to plot the graph for our applications, for our thesis. But we can easily find that this is the minimum one, 7.33. Uh, so this is for which separator, which splitter. You can see that this is for the splitter is 21. So that means out of our total uh, total 5 splitters, if we can use the A's as the as our that is the separator, then we have to consider S21 as the separator. S21 as the separator because S21 has the minimum count square sequence, that's minimum error. Okay. Now, what we have to do? We have to consider the next variable. So in our data set, we have total two, that is independent variable, and one dependent variable. Uh, Between the two, that means the two independent variables, one is S. We have already considered that, and we have already determined that if we consider the S, then we have to consider S21 as the separator. Now we have to think about the other variable. So here just only one other variable is place of living. If we have multiple variables, then one by one we have to consider. So here the place of living is our next variable we have to consider. Now place of living is the village, city, okay, type, just only two types, village and city. Okay, for implementation, actually we have to encode these things like village equal 1, city equal 2, in case of the implementation. Okay. But for maybe manual calculation, no need of encoding. But if you implement this, then you have to encode. Okay, then IQ score, the same IQ score. The village, this first observation, second, third, so observation 1, observation first one, 4, 5. So the first observation, that means the first people uh, lived in village and IQ scale. So this is now we have to consider the place of living and IQ. To consider the place of living, considering the place of living, we have to think about again the splitter. That is, how many splitters we can have using just this place of living feature. So here we can see that this village and city, two kinds of people. That means the variables, the category, just only village people and city people. So it is easy to see that just only one splitter is enough to split the data. One splitter, that means whether the people is living village. So that means if yes, then place of living is village. If no, then the city. Okay? So this is very simple. So that's why considering place of living village as the separate. Okay, considering place of living as the village as the separate. So consider that place of living as the separate. If we consider the place of living as the separator, so that means these values are not numeric values. Okay, so determining the determining the separator is easy for that. No need to follow the similar process like the age. So the considering place of living equal village as the separator. If we consider this one as the separator, then again we have to think about the left side and right side. So that means uh, if we can construct a tree like that is place of living, uh, place of living equal uh, village. So this is our separator. Place of living equal village. Again, we can say that uh, the true or false. So this is true and this is false. We will place the true in left side and false uh, elements in right side. Okay, so in such a case, if we can see that the place of living is village for the first one, first person, first observation. Yes, place of living is village. If the place of living is village, then the IQ score is 1. The second one, so that means in this case, the IQ score is 1 plus. The second observation, the place of living is city. That means the condition is false here. If the condition is false, then we have to place the IQ score in right side. That means 3. The 3 we have to place in right side plus. And then the next one, that is the village, again village. Okay, so IQ score is 1. The fourth one is village, IQ score is 4. And fifth one is city, IQ score is 5. And sixth one is city and IQ score is 2. Now what we have to do, we have to take the average of this. So that means divide by 3 and we have to divide by 3. Then you will get like 1 plus 1 plus 4, that means 4, 5, 6, 6 by 3 equal. Here is it. Average IQ score of left side instances will be 2. And average IQ score of right side instances, so that means 3 plus 5 plus 2 divided by 3, you will get 3 from this one. So we already get our prediction based on this criteria, place of living. And the possible number of splitter here is just only one splitter. Now, what we have to do, we have to determine the sum of square residuals following the same philosophy that we have discussed for the case. Okay, so consider that the left side instances are the village. So this will be in left side. And here is the village. This will be in left side. And this is the village. So this 4 will be in the left side. But the prediction for the left side is 2. Okay, then we have to find out the square error. Okay, so this is 1, the original IQ square is 1, but the prediction is 2. And then this one, original IQ square is 1, but the prediction is 2. Original IQ square is 4, but the prediction is 2. So square error we have determined for the left side instances. And for the right side instances, original IQ score, the right side of the city. So that means this one will be right side. 3. So here is the 3 original. And prediction is 3.3. Another city people, here is the 5. This is the 5, original 5. And the prediction is again 3.3. And 2, here the 2 is the original IQ score, but the prediction is 3 based on this tree. If we do the math, then you will get 10.667. 10.67. That means here in this case, you will get 10.67 as the sum of square residuals. That means error. Okay, now here just only one separator. Okay, if we have multiple separators, then again we have to that is see which one is minimum one. That means we have to find out the minimum one. But here just only one separator. That's why we can easily find out that this is the minimum. The 10.66 is the minimum one for place of living. Okay, before going to the next phase, next step, I want to discuss a little more here, because in this case we have just only two categories, areas and city, two categories. What if we have another category like city, village, and capital city? So capital city, capital. So in this case, how many we can say that uh, splitter? How many splitters we have? In such
Three.
a case, how many splitters we have? Okay, so the number of splitters specifically we determine using this equation. If we can place that is just in here, so 2 to the power 3 minus 1 minus of 1. So that means this is the case. So 2 to the power 2 minus of 1. So that means 2 to the power 2 means 4 minus 1. It will return you 3. That means you will get 3 splitters from it. So like one splitter would be, considering place of living is village. On that case, just village people will be on your left side, and in your right side, we will get the city and capital city in your right side. And again, considering place of living equal city. So another separator you have to consider, the considering place of living equal city. On that case, and only the city people you have to consider on the left side, and on the right side you have to consider the village and capital city. And third separator will be like considering place of living equal capital city as the separator. On that case, the capital city will be in left side, and village and city people will be on the right side. Is it clear?
Sorry, is it mandatory to put all the true values at the left side, or
No, it is not mandatory, but you have to follow just one principle.
okay, sir? Thank you.
Okay, so here is for the three, for the case of the three. And how about the four? That means maybe village, city, capital city, and maybe you can say metropolitan city. Okay, so we have now four variables. Then you have to just put the values here, and you will find how many that is splitters we need to consider. Okay? Like here, if we consider the four, then just only four splitters will not be enough. Okay, like in case of the three, we consider the three splitters. In case of the four, you have to consider also like this, uh, place of living equal village and city. This is the split. So considering place of living equal village and city, so it will just divide again. So is it true or false? That means true. Here is the false. In such a case, maybe you will get in left side you will get the village and city people, the village and the city people, and in right side you will get what? You will get the just only another capital city and also the metropolitan. Okay, so you have to consider this kind of combinations also. So this is one combination. You can combine like the village and capital city. So in that case, the village and capital city will be in your left side, and other two will be on the right side. Okay, so that means the combinations you have to consider and determine the sum square residuals for each and every splitter. So is it okay? Is it fine? Any question here?
Yes, sir. No problem.
Okay. Thank you. Um, okay, so in this case, we can see that the minimum sum square residuals for A's is 7.33, and minimum sum square residuals for place of living is 10.67. Now, if we compare the A's and the place of living, the A's and place of living, we already considered all the possible combinations of splitters, different splitters of A's and place of living. But from the A's, the minimum one, or maybe the optimal one, is 7.33, and if we consider the place of living, the optimum one is 10.67. Then compare between these two variables now. Two variables, variable A's and variable place of living. This one give you the minimum sum square residuals first. In this case, you can easily see that the 7.33 is minimum. That means I have to consider the A's as our first discriminator, or we can say that in the root of the regression. So, here it is. So we can say that the A's and the place of living. So here is this. That is, we have to consider the A's. The A's, okay, A's as the separator first. That means in our regression tree, you have to consider this. And for which separator? This 7.33 is for the S21. So this is the separator. Is less than 21. This is the separator. And if yes, that means it's true, and if no. Then what will be the our, that is the prediction? Prediction will be For the left side instance, this is 1.67, here is 1.67, and the right side is 3.67. Okay? Here the right side is 3. So this will be the initiation, or maybe you can say starting of our regression. This is the start, or this is the root is less than 21. This is the root of our regression. Okay. Then what we have to do now? We have to expand now. Expand. So that means what we have to consider after that. So for that, actually this is 21. This one will partition our total data set into two parts. Like here, you can say that the A's and the IQ score. Is 21. This is the is 21. The is 21. If we can plot the data set, we can see that this this is already partitioned our IQ score, or maybe our data set, in two segments. In one segment, these are the elements, and in other segment, these are the elements. Okay. So now, again, we have to consider this part and also other part. So this part, that means these three instances will be in the will be in the left side. Okay? That means S less than 21, and these are the S greater than 21. So consider one by one. You have to consider maybe S less than 21 first, and then we will consider again S greater than 21. But considering that our total data set will be divided in this way. Now, is less than 21 is this, and is greater than 21 is these are the instances of that. So at first we have to we want to consider this part. That means the expansion of G in this way. What will be the expansion? After that, what will be the next consideration? If this is the tree, then we can see that the average is 1.67. So this is the average, or we can say this is the prediction. But we want to predict more precisely. Okay, so that means we want to expand more. Okay, now, so this is the data set. In this data set, we can say we have just only three instances. And again, we have to consider the A's and the place of A. So, now, as we have just only three instances, so now 8, 9, and 10. Again, these are the numeric values. 8, 10, and 12. So in case of numeric values, what we have to do, at first we have to sort. So we will sort that, and the corresponding IQ score will be changed also. So here it is already sorted. So the next step is find out the average of consecutive two numbers. So consecutive two ages. Consecutive two ages is 8 and 10. That means the average is 9. And consecutive next consecutive two 10 and 12. So the average will be the 11. Okay, so that means 9 can be the separator, 11 can be the separator. So considering 9 as the separator. If we consider 9 as the separator, 9 as the separator. So in this case is 9. If we consider this one separator, then it will again divide the data set like maybe less than 9, that means just one instance, and that is this one less than 9, and these two are greater than 9. So IQ score of this one will be in the left side, and average IQ score of these two will be on the right side. In this case, just only one instance. So in left side, average IQ score will be 1. And in right side, average IQ score will be 3 plus 1 divided by 2. That is 4 by 2 or 2. It will be and carry it. Average IQ score of left side instances, this is 1. So, 1. And 2, this is the 2. And again, same thing. That means we have to determine the sum of square residuals. So sum of square residuals we have to determine. This in this case, sum of square residuals will be in this case the first one. That means considering is 9. In left side just one element. This is original. Original is 1 minus of the prediction is 1. Original is prediction is 1. So sum of square residual, that means we have to take the difference and square it, plus the next one is for the right side. The right side, first element of the right side is 3. And this is 3 original minus of the predicted one. The prediction is 2. Plus again another one, this is the 1 minus of okay, if we do the math, then 1 minus 1 you will get 0 plus 3 minus 2 square, that is 3 minus 2 is 1, 1 square is 1, plus 1 minus 2, this is minus 1 square is just 1, you will get, and this is the sum of squares. Okay, next we have to consider the S11 as the separator. Now if we consider S11 as a separator, then the left side will be this 2, that is the less than 11, and in right side there will be just 1 to is 12. The corresponding IQ score, we have to think about the average of these 2 and average of this 1. So this 2, average of this 2 will be 2. Here is the 2. And average of this one is just 1. And if we do the math for the sum of square residuals, you will get 2. Now we can see that the minimum sum of square residuals is 2, but this 2, it can be 9 or it can be 11. So that means we can take any one, 9 as the separator or 11 as the separator, because the sum of square residual is same here. So we can take any one. But before taking this, we have to consider also our other variable, that is the place of t. You have to consider the age and find out the possible splitters, and also find out the which splitter will give us the minimum sum of square residual. And now what we have to do, we have to consider the place of living in this another variable. So here is the place of living for just only the 3 observations. The place of living and corresponding IQ score. Again, considering place of living is village as the separator, because we have approximately 2 categories, village and city. So only one splitter will be enough. So average IQ score for left side instances will be, so that means village. So you can say place of living is village, and this will be right side and left side. In this side, IQ score village people is 1 and 2. 1 plus 1 divided by 2. So that means it will be an average IQ score for right side instance. If this will be 2 people, 3. Just only one element. The average will be that number. Now, what we have to do, we have to determine the sum of square residuals. If we determine the sum of square residuals, we will get Sorry, if we do the sample space, we will get 0. How can we get the 0? For left side instances, which will be on the left side. So this one and the will be on the left side. That means 1, this is the original IQ score, and the prediction is also 1. We take the square sum. And then left side another element is this one to this. So here is also the IQ score is 1. 1 minus a prediction. Prediction is 1. Plus right side instances. So right side instances is just only one right side with the people. The original is 3. So 3 and the prediction is also 3. This is prediction. So that means you can see that no difference. Okay? So 1 minus 1 is 0, square of 0 is 0. 1 minus 1 is 0, square of 0 is 0, and 3 minus 3 is also 0, square of 0. So that means here is 0. Sample space it was 0. Okay, so for the case of the place of living, it is 0. Now what we have to do, we have to compare between two variables, that is place of living and age. So we can see that here is this minimum sample space residual for age is 2, and minimum sample space residual for place of living is 0. This one is minimum, the minimum is 0. Okay, that means we have to consider the place of living here in this. Here, the place of living equal to 0. So this is the second stage splitter. We have to consider. In case of the place of living, the left side and right side, okay, the average of left side is 1 and average of right side is 3. If this the condition is true, that is left side, average is 1 and right side, average is 3. So this is the prediction. Okay, place of living, specifically the place of living. Place of living only divide the data. Again, divide the data, right? The place of living equal to this. This is splitter. Divide our data, this data in two parts. The place of living, village and city. You can say that the village and city. So here, this is one is the village, two is the city. Okay? Two is the city. So IQ score, here we can see that this is the 3 IQ score for the city people and 1 IQ score for the village people. Or we can say that the left side instance is village and left side instance is village and right side instance is city. So again, 2 instances in the left side and 1 instance is in the right side. So that means this separator will separate out this data, though it has just only 3 instances, but in left side we have 2 instances, so village and this is the village, and in right side we have just only 1 instance. Okay. That means we can see that here is that in left side we have 2 instances and in right side we have 1 instance. So if we have just 1 instance, that means no scope to expand. So that means just only one observation. This branch will not expand. If we have 2 instances, this branch can be expanded. So if the both of these instances have the same, that is the same data, then maybe no need to expand it. But if we can see that different data, then we can expand it. But we can have another stopping criteria actually, because when we need to deal with the large data set, not the data set like this is 6 instances. on that case, we have to have some stopping criteria, and one of the stopping criteria is that is the when you have to stop expanding. You can use the threshold for that. That is, if the threshold is less than or equal to, or maybe another threshold, then then we can stop expanding. Like here, I applied this threshold. So, the number of instances for this node, number of instances now two, only two. So I can stop here. I can expand further, but for this condition, I can stop here. If and for the case of the original data, uh, we have to stop expanding the tree. Maybe for the case of the 10. So that means if we have 10 instances in a single node, we will stop and just use the average as the prediction. So in this case, I just stop expanding here because I already reached at my threshold, the 2 instances. Okay, so I can stop here. Before that, can I stop here in this case in the previous screen? Yeah, if my threshold is 3, then I can also stop before constructing the next level. That is in this. Because in left side it has 3 instances, and right side it has 3 instances. So that means if the threshold is mentioned as 3, then I can stop here. But in my case, I use the threshold 2. That means I stop expansion of the tree when I can reach the just only 2 instances. Okay. So I will not expand this part anymore. Now what I have to do, I have to construct think about this side. That means when this condition will false. If this is true, we already expand this side. But how can we think about this? That is for the case of the false. Okay, that means I have to think about the different another portion of my data set. We already have seen that we already considered this data, but we didn't consider this part. Okay? So I have to consider now this part. That is observation 4, 5, and 6 with 30. Okay, any question after this slide?
No, sir.
Okay. So is it easy or difficult?
No, sir.
Okay, then.
Sir, we didn't do it yet. That's why we are not understanding. It's easy or difficult. But we are understanding what you are telling us.
Okay, good. Okay, after this class, maybe you can just go through the class and also do it by yourself and
Yes,
uh,
sir. Then maybe we
understand.
might find our problems.
Okay, good. Okay, now consider the other side, other part of it. Again, here is 3 instances, A's and plus of data. We have to follow the same procedure. That means we have to consider A's and find out the possible splitters and also determine the sum of the square residuals for each and every splitters. And next we have to consider the place of living and also find out the splitters and possible sum of the square residuals. The same thing. Like here, considering the A's already sorted here. In this case, the average of two consecutive numbers will be 32.5, and average of these two consecutive numbers will be 37. So now considering the A is 32.5 as the separator, if you consider that, then what will be in left side? So 32.5 is our is less than 32.5. In this case, 32.5. So here is the 35 and 30. So in left side, this will be in our left side. That's 30. That means that in this case, this is left and this is right, and this is for 2 and this is. So in left side, 32.5. So left side will be just only the 30, and the corresponding IQ score will be 4. The corresponding IQ score will be 4. And in our right side, 35 and 60, the corresponding IQ score will be 5 and 2. So that means we have to take the average of these. Yeah. So this is 5, 2, 7, divided by 2. Average IQ score left side is 4, this is 4. And average IQ score of right side 3.5. And what we can do, we can also determine the sound viscosity. If we can find the sound viscosity residuals, I think no need to show it again. You will get 4.5. And for considering is 47.5 as the separator, in this case, this will be in the left side, and this one element will be on the right side. Average IQ score of left side instances will be 4 plus 5 is 9 by 2 is equal to 4. And another side it will be just 2. And sound phase residuals, if we can determine the sound phase residuals, we will get the zero. The minimum sound phase residuals will be 0.5. 4.5 and here 0.5. 0.5 will be the minimum sound. But this minimum we will get for 47.5 is 47.5. Is 47.5. So that means for the case of the A's, we have to consider the A's 47.5 as the separator for minimum sound residuals and minimum error. Okay. Next, what we have to consider? We have to consider the place of living again. Here is the place of living. The place of living is city and village. That means just only one separator will be enough. Place of living is village as the separator. The village just only one people here, and city two people. So city two people and village one people. IQ score for the case of the village will be for left side, and for right side, average IQ score will be 5 plus 2 divided by 2. 7 divided by 2 will be 3.5. If we determine the sum of square residuals, you will get the 4.5. As no other the separators, just only one separator we can have at this space. So the minimum sum of square residuals for the place of living also 4.5. Now, what we have to do, we have to compare the minimum sum of square residuals between A's and place of living. Okay, so that means 0.5 and 4.5. we can easily see that the minimum sum of square residuals will be is is, but will be the separate? The separate will be is 47.5, and there it is. If we can plot that, then the right side element again, if I apply this one, 47.5 is greater. In right side, after 2 S21, we have to consider S47.5 as the separate. If we consider S47.5 as the separate, then left side and right side like this two are false. If this one is true, if this one is false. So for that case, the average IQ score of left side will be 4.5 and right side will be just 2. There is 2 and another 4.5. And now you can see the number of instances. Okay, so 47.5. If you consider this separator, then in left side is 47.5. So left side increase will be in left side. How many instances are there? 2 instances. And in right side, just only 1 instance. So 2 instances and 1 instance. If this is the 1 instance, no need. Sorry, there is no scope of expansion. But in this case, we can expand. But as I mentioned that I use the threshold 2. That means if it is 2 or maybe less than 2, then I will stop expansion. I can stop here. Okay, then this is the whole tree, and this is called the regression tree. So this is the constructed regression tree for our okay. Now from this regression tree, can we answer like some queries? Like maybe one people just uh, he or she has 34 uh, 34 years old and lived in village. Maybe he or she is living in a village and is just 34. Can this tree answer or maybe predict the IQ score of this person? So what we have to do, we have to feed this data to this tree. The first consideration here is S21 or not. Age is less than 21. Age is less than 21? No. Age is 34. 34. That means it's greater than 21. So move to this direction. You have to move this direction, that is 34. Now again consider the age. Again consider the age. Age is 47.5. Less than 47.5. Yes. The age is less than 47. Yes. Yeah. So what will be the prediction? The prediction will be the 4. That means predicted IQ. The predicted IQ will be 4 for this person. So this is how the regression tree predicts the continuous. That is 4. Any question?
Sir, the threshold is fixed or we need to imagine it?
That is the for expansion, tree expansion. You mean the tree expansion threshold?
Yes, yes, sir.
Okay. Uh, so, so in the exam, you will get the threshold value. Okay? That is maybe the threshold for function threshold. You have to consider is 3. Then you have to step on 3.
Okay.
But in the programming, you have to define it by yourself. If you do the express code,
Okay, sir.
and if you just call some library function, then it is already use the default value. Okay.
Hmm.
So that's the case. Okay.
Okay, sir. Thank you.
Okay. So
I
uh, any
means this
question?
whole the procedure. So this whole procedure is fitted in a computer or a framework. We can just call it and use it, right?
Yeah, you can call it and use it.
Okay, sir.
But
Thank you.
that is not the goal of computer science. Um, why we are studying this one? Because we have to know the inside. We have to know the internal process algorithms. Okay? Otherwise, all the algorithms are available. No need to, I think, know any algorithms. If you are outside the computer, you can
I
just
was
plug
actually
and drop on.
wondering how can I write a code like something like this and everything. Although this one is pretty simple in a way, but I mean
Yeah,
for the other algorithms, how can I? But that is why I
yeah,
asked if these are already installed in libraries or frameworks.
yeah. It's already in the library. Okay, then what we can do next? Let's see, regression trees. These are the references. Okay, so this is the today's lecture. Specifically, I have to go somewhere else at 8 p.m. That's why this is the we can say that it's the short lecture. But I have already uploaded uh, one of the lecture on data camp introduction. So please go through that lecture because some of you already maybe uh, started the data science, the data camp coding, but still many of you didn't start. So if you have any problem on starting the lecture will help you because I already uploaded the lecture
Sir, here
in
the
our
start
exclusive.
course is given. We will start give the start course and see the lectures, videos.
Uh, okay, you
Give
can
the
start from the data camp, or uh, I have already uploaded one of my lecture. Okay? That is how can we start the data camp and uh, what will be that is the optimal steps or optimal way to learn from the data camp. I already
Okay,
that is
sir, we will see that.
you
So
can
another
see
thing
that
about
lecture.
the deadline, if you could just extend it. Most of us are office going people. It's very hard for us to finish it with the 29th October.
Exactly. I think this one is very simple. Okay, just try. If you fail to do that, then I will explain later. No problem. But this the first assignment is very simple. Okay, so do it. Uh,
Okay, sir.
and
Thank you so much
Sir,
for
other
your words.
assignment, I will later assign other assignments also. Hello. Uh, hello. Anyone have any question?
Hello, sir.
So,
Yes, sir.
I'm opposed. Okay.
Sir, here
What?
I'm saying that. Yes, sir. You are, sir. Here is a assignment about introduction to Python, right, sir? Do we all have to do that? Those who are no familiar with Python.
Yeah, I think this is the assignment. This is the first introduction to Python for data science. Okay. So go through the assignments. Maybe for you it will take just only few hours, 1 or 2 hours you can do that. as this one is a course assignment, I think it's better to do that. And you can expand, that is, explore by yourself some other courses. Lots of courses are there. And learn. Mahfuz, can you hear me? Am I audible?
Yes, sir, you are audible.
Okay.
Sir, skill
Sorry, sir,
assessment
my
test in
network
data camp.
disconnected.
Okay,
Sir,
Mahfuz, as I said that is, as this one is course assignment, please do it. Okay, please do it. Whether maybe you're already familiar with it, but please do it. You have the
Okay,
option
sir.
to explore other courses. Okay, okay. You can explore other courses. Mr. Maksum,
yes, sir. The skill assessment test in data camp
uh,
is mandatory for assignment.
yeah, actually, in this course, we have some points in assignment. As I mentioned, that is the those points really come from the data camp assignments. Mr. Mansur.
These are okay.
Actually, not only theory, we have to learn some practical works. I think the data camp assignment will help you to learn the practical, specifically the Python, or maybe you can pick some of the courses from R also. But I recommend you to go for Python, specifically for Python is commission language. Okay, so thank you very much for attending this class. If we don't have any other question, then maybe stop here. So thank you for attending this session.
Thank you, sir.